Hi, Assalamualaikum warahmatullahi wabarakatuh. Today we are going to enter a new chapter, a chapter about alcohol. We call alcohol hydroxy compound for chapter 8 and lesson starts at 72. Today, synthesis of alcohol. Apart from being the main ingredient in alcoholic beverage, what are other main uses of alcohol and phenol? We need to know that. The general formula of open chain alcohol is CnH2n plus 1 OH. We need to know how to explain the physical properties, solubility and boiling points of alcohol. And we also need to draw, classify and name primary, secondary and tertiary alcohol according to IUPAC nomenclature. There are three reactions to prepare alcohol which we are going to learn in this lesson, which is hydration of alkenes, nucleophilic substitution of haloalkanes, and addition of Grignard reagent to carbonyl compounds. We're not going to learn fermentation in detail because that's biology. As you can see in this visual, grapes, grains, rice, fruits, vegetables, they fermented these carbohydrates to become ethanol in alcoholic drinks. As Muslims, we are prohibited from drinking alcoholic drinks. In the Quran, chapter Al-Ma'idah, sentence 90, it is clearly stated here that we cannot drink intoxicants, al-khamru. This is referring to the alcoholic drinks which will damage our health and makes us do things that are not human or unthinkable. So we must not be near any of these drinks. The functional group that is present in alcohol is hydroxyl group, OH. We call these homologous series as alcohol. There are two types, aliphatic and aromatic. Aromatic alcohol is also known as phenol. The general formula for aliphatic alcohol is CnH2n plus 1 OH, whereby OH will be attached to alkyl group R. The IUPAC nomenclature of this compound is having OL at the back to replace E for alkane. For example, if we have ethane and we add a OH group to it, we are going to get ethanol. And if we have 3 carbons, it would become propanol. An aromatic alcohol is the phenol. Phenol is when you have a benzene ring, attached to it is a hydroxy group. This is the Pauling structure and this is the Kukul structure for phenol. The simplest aromatic alcohol is phenol, and it is different from open structure alcohol by having the hydroxy group attached directly to the aromatic ring. Let's look at the physical state of alcohols. For a simple alcohol that is having less than 12 carbon, it is a colorless liquid, but if it has more than 12 carbon, it is a solid. So how many carbons does a phenol has? 6, right? So it can be a colorless liquid, or if it has more than 12 carbon because of the substituents attached to it, it would become a low melting point solids. Is alcohol soluble in water? Yes. For smaller alcohol, for example, methanol, ethanol, propanol, and tert-butanol, they are basically miscible with water because hydrogen bonding can occur between them and water. But as the number of carbon increases, the R part, the hydrophobic area, becomes larger. Therefore, the water solubility will decrease. Shown to you here is the hydrogen bonding exists between the electronegative part of hydroxy compound with the electropositive part of water. You should be able to draw this when asked in the exam. Alcohol is also used in cooking, in making perfumes, in cosmetics as cleanser. It also can be used as fuel, solvent in the lab, and also synthetic intermediate. Alcohols are classified based on the carbon atom that is attached to the hydroxy group. The first category here, methyl alcohol, has OH bonded to methyl group, as we have seen it here. The second one is primary alcohol, whereby the OH group is bonded to a primary carbon. As you can see here, this is a primary carbon because it is attached to only one R, because in this R, there is one carbon attached directly to it. A secondary alcohol is a compound when OH group is bonded to a secondary carbon atom. As you can see here, this carbon is a carbon atom, is a secondary carbon because it is bonded to two R's. Next is tertiary alcohol. The hydroxy group is attached to a tertiary carbon. As you can see here, there are 1, 2, 3 R's that is attached to this carbon. So this carbon is named tertiary carbon. Therefore, this is a tertiary alcohol. The last category is aromatic alcohol phenol, whereby the hydroxy group is attached directly to the aromatic ring. Practice 8.1, the question is, draw all isomers of alcohol C4H9OH and give their classification. The first compound would be a straight chain butanol. Let's draw the 4 carbons here. And this is called 1-butanol. The classification is a primary alcohol. The second compound, let's draw a chain isomerism. So we draw a chain over here, a branching over here. And then there is our 4 carbons. And here is the OH. So the OH hydroxy group is attached to another primary carbon. Okay, the third one, let's do a positional isomerism, where we're going to switch the position of the hydroxy group. So CH3 would be here is the OH group, and we have 1, 2, 3, 4. This is the 4 carbons. Okay, as you can see here, The OH group is basically attached to a carbon that is a secondary carbon. Therefore, the third compound here is the secondary carbon. Do we have any other isomer? Yes, I think so, because we are going to draw this CH3 and then one branch over here, CH3, and one branching over here, CH3. Yeah, and this one is attached to OH. So this is basically an OH attached to a tertiary carbon. Right. So this is basically a tertiary alcohol. I think this is all the isomers of 4 carbons alcohol. Try do tutorial chapter 8, question number 1. It is a similar question with this one, so I hope you can do it properly. Let's turn to your mind map for alcohol in page 293. This is the left part of the page, and we are going to learn the 3 reactions to prepare alcohol. The reactants are alkenes is going to undergo electrophilic addition to produce alcohol. The second one is haloalkane undergoing nucleophilic substitution to produce alcohol. And then the third one would be the Grignard reagent react with carbonyl compound to form primary, secondary, and tertiary. All of these reactions we have learned previously. Right, we're going to look at only one example of fermentation. Carbohydrates sugar C6H12O6 is going to use yeast Saccharomyces cerevisiae and produce ethanol. Right, example 8.2 is giving us a revision of electrophilic addition on alkenes using H2O, H3O+, and or sulfuric acid. This reaction is going to form 2 products, major and minor, but how are we going to determine this? By using Markovnikov rule. What does Markovnikov rule say? The hydrogen will be attached to the carbon that has most number of hydrogen. So the major product is H attached to carbon which has H, whereas OH is attached to carbon that has no H. So this is the major product. And for minor, it's the other way around. OH is attached to the carbon that has hydrogen, and H is attached to the carbon that has no hydrogen. The second example is the electrophilic addition when we are using sulfuric acid. We are also using Markovnikov rule here. So where is the double bond? It's here. So we should be able to draw how many hydrogen there is in the restricted carbon. So there is actually 1 hydrogen here on the left carbon, but there is no hydrogen for this carbon because it already has 4 bonds. So what is the answer? Yes, the major product is when you have OH attached here and hydrogen attached here. because we are going to remove this double bond. So basically, this is the major product because H attached to the carbon that has more H. OH is attached to the carbon that has no H at all. And we remove the double bond. The minor product is when OH is attached to the carbon that has hydrogen. And the hydrogen from sulfuric acid will be attached to the carbon which has no hydrogen at the beginning. Okay, let's do the third example, 8.2. This is another hydration and addition of sulfuric acid, electrophilic addition. The reactant is given to you. Here there are two double bonds. So, according to Markovnikov rule, we are going to add OH at the carbon that has no hydrogen, H to the carbon that has more or most hydrogen. And what about this one? This one, we are going to attach OH over here because there is no hydrogen there. And here we are going to attach hydrogen because there is a lot of hydrogen here, more than this one. So here is the major product. Let's circle this. Is this carbon. As you can see, it is attached to this methyl group, and this is this methyl group. And we have OH over there. And what about this one? This carbon is basically this carbon, and this is another restricted carbon that is now having two hydrogen attached to it. So that's your major compound. The minor compound, on the other hand, would have, okay, let's remove our drawings over here so that we can redo the minor product. I'll use blue now. The minor product is when we attach OH over here and H over here. So this carbon would be this carbon, yes? Alright, and then we are going to attach H over here and OH over here. Yes. This is basically the carbon that is involved to produce the minor compound. The next reaction to produce alcohol is the nucleophilic substitution of haloalkanes. We have just learned about SN1 and SN2. So what type of haloalkane is this? It's a tertiary haloalkane. So, will it undergo SN1 or SN2? Yes, well done. It will undergo SN1. That is having two steps mechanism. Right. So, what is the product for this reaction? Yes, simply replace the chlorine atom with a hydroxy group. Now we move on to Grignard reagents. How do we produce a primary alcohol? We will simply use a methanol. So what is the product for this reaction when ethyl magnesium bromide reacts with methanol and then being hydrolyzed? Yes, it will produce a propanol. Let's look at the second question on Grignard reagent, example 8.4. We are given a reactant which has an R, which is a benzyl over here. This is a benzyl magnesium bromide. And then we are going to react it with the methanol. We are going to get a primary alcohol. Let's look at the answer. Benzyl will be attached at the hydroxy carbon, and the two H's that is attached to methanol would be attached also to the hydroxy carbon. So this is our product, a primary alcohol. Alright, example 8.5 is the preparation of a secondary alcohol by using Grignard reagents and an aldehyde. So we are going to get a reactant. This reactant is an isopropyl magnesium bromide. Okay, the R from the Grignard reagent can be attached directly here to the carbon that is attached to the hydroxy group. And after that, we are going to take the R from aldehyde, a methyl, put here, and the hydrogen, put here. So here you go. This is basically the secondary carbon because it is attached to 1 and 2 carbon. So we are actually producing secondary alcohol. Okay, for question number 2, let's look at this phenyl magnesium chloride. We are going to produce a secondary alcohol where the phenyl part is going to be attached from down here to the hydroxy carbon, and then the ethyl coming from the 1, 2, 3 propanol is going to be attached here, and then the hydrogen from propanol is going to be attached to the right side here. So here you go, we are producing another secondary alcohol. The last type of reaction that we're going to look at is the preparation of tertiary alcohol by using a propanon over here. So we are going to get a tertiary alcohol. Why? Because we have 3 types of R. R coming from the Grignard reagent, R coming from the ketone. So there are 2 metals here attached here and here, and then 1 more R attached from down here. So we are basically producing 1, 2, 3, 4, 5, 2-methyl pentanol. The second question on how to produce tertiary alcohol by using Grignard reagent. Yes, this is the reactant. We have a cyclic compound over here attached to MgCl, a Grignard reagent, and we are using butanol. So as you can see, also we have 1 R over here from the Grignard reagent, 2 R, a methyl, 3 R, and ethyl. So we are going to produce, here is the tertiary alcohol. Voila! Okay, practice 8.2 is for you to do. I'm going to wait for your answers before making another set of video for this one. Do also question number 3 from the tutorial. Good luck! Alhamdulillah, thank you very much for watching. Let's continue to lesson 73.